Hello, this is Ryan Spring from Tohoku University. Um, if you are wondering about this one that says 3 plus different measures of 2 data sets, you have probably clicked on this black circle here. To quickly explain, what is the difference between these three? If you have just 2 data sets, for example, pre-test, post-test, this is the one to use still. Or if you're comparing just 2 survey questions, for boys and girls or something like that, you're still going to use this one. If you have 3 data sets, you're going to want to use this one, or 4 or 5. So for example, if I'm not comparing males and females, but males, females, and other, who don't identify as either male or female, then if you have the same survey questions and you're comparing those, you're going to want to select this one for 3 data sets. Similarly, if you're doing a pre-test, post-test, delayed post-test, you're going to want to use this one. This tool here is used for when you have the same 2 groups that you're trying to compare. For example, you took lots of survey questions and you want to compare males and females, or Class A and Class B, or if you have pre and post test data. However, this one is used when you are not measuring everything in the same scale. So some good examples include, for example, if I'm taking lots of survey data and I have 20 questions about happiness and 10 questions about motivation and 3 questions about enjoyment, I can add the happiness questions together, I can add the enjoyment questions together, I can add the motivation questions together, but it's not the same number of questions, so it's not measured on the same scale. So I can't really compare all 3 of those to these 3 data sets. But if I'm trying to compare, for example, between males and females for these 3 amalgamated systems, the motivation questions, the happiness questions, and I forget the other one I said, but if you're trying to compare those 3 things, rather than doing 3 of these tests, one for this, and one for this, because they're measured on 3 different scales, you can't really lump them all together. You have to compare them individually. These two requires that everything is calculated on the same scale or measured on the same scale. You can use this one to ensure that we're not going to make a type 1 error thinking that there's some difference when there isn't one, especially if you're comparing lots of things. So for example, if you have pre-treatment and post-treatment writing, and you use, for example, one of Christopher Kyle or Xiaofei Lu's tools that give you a lot of different measures of lexical and syntactic complexity, those aren't measured on the same scale. So you can't put them all together into the same giant data set. You've only got pre-test and post-test data. You want to make comparisons, but you want to make comparisons of a lot of these things. So instead of just doing tons of comparisons, which you could potentially do as long as you're very careful with interpretation, you can also click here to use hotelEng's t-square. So the first thing that you want to do is tell it how are your data sets paired or not. So if you're looking at pre and post test data and you have several measures of pre and post test data, you can click yes. But for example, if you have males and females and you're looking at the males and females scores from these different writing indices, or you're looking at males and females scores on these various survey questions that don't have the same scale, you can click no. Then you want to tell me how many pairs of data, not how many data points, but how many pairs of data. So if I have lexical complexity, syntactic complexity, and lexical variety, that's 3. I should have those for males and females, or for pre and post, that's 3 pairs of data. So you can put the number 3. Okay. Then you set up the test. It automatically says pre and post, but you don't have to care about that. If you have males and females, it doesn't matter. You can put your own naming there. The way to upload the CSV is essentially the same, but I do request for this one that you, for example, put your pre-test data in column A, your post-test column, sorry, your post-test or your matched one. So if I'm looking at fever pre and post, or fever for group A and group B, I want to put them next to each other, then pressure, etc. So if I'm doing those, I want to make sure that they are in that order. Then you can click calculate to get the scores. I'm just going to quickly upload this one, okay, and compare. Okay, and then what it gives you the t-squared metric, which you can use to determine if there's any differences in any of those groups anywhere. Okay, which is converted into an F statistic. It gives you a p value, and you can also get a measure of effect size. It does tell you if there's a difference or not, yes or no. You can get p-values for these as well, but just to be safe, I included simultaneous 95% confidence intervals, but Bolin-Ferroni is the one to really probably look at. And essentially, if this range does not include 0, then you're kind of outside of the range, and we're going to say that there's probably no difference. I mean, it's within the range. But for example, this goes from a negative number to a negative number. It does not include 0, so I can be very sure that there's a difference there. Or if it's from, for example, 7 to 12, that does not include 0 either. It does not include any negative number, so that would also get yes. But that's essentially how this test works. Okay, just remember to select paired or not, how many pairs of data, not how many data sets, but how many pairs. And remember, when you're uploading your CSV, to make sure that you have data 1 and then the pair, data 2 and then the pair, like this.